Okay, we left off here, so I'm sorry about the confusion there. We're going to talk about average atomic mass. If you notice on your periodic table, you don't have a whole number for mass as opposed to here where you had a whole number for mass. Okay, if you look at copper, for example, okay, copper, for example, on your periodic table, number 29, the mass on there rounded to the 10th place is going to be 63.5. The mass on your periodic table is an average atomic mass weighted by the abundance of the different isotopes. So what is an isotope again? And why? Oh my gosh, this thing. Ugh. What is an isotope? We talked about that yesterday. Protons and neutrons are not always equal, right? Okay. So we have different isotopes that are out there, and the mass on the periodic table is based on a weighted abundance of those. So for example, carbon is 12. Well, there's carbon 12 out there. There's carbon 13. There's carbon 14 out there. This number then represents the average atomic mass. So which one of these would be more prevalent based on this value? Yeah, this one. Okay. Now, this number here is higher than 12 because these isotopes exist. Okay. These guys are out there in nature, and so they're going to bump this number up from 12 just a little bit because there's more of, there's some out there. So how do we calculate this average atomic mass? We're going to figure that out here for, oh my God, this program is driving me nuts today, you guys. Sorry. Okay, why can't I see all of this slide? There we go. Okay, so here we have iodine. Iodine has 3 naturally occurring isotopes. The first isotope is 127, and that is 80% of the material that's out there. The second isotope is 126, and that represents 17% of the sample. And 3% is 128. Okay, so that means if we have a sample of iodine out there, okay, and we have 100 atoms. So let's pretend that we've got 100 atoms of iodine in this sample. 3 of those are going to be 128. Okay. 17 of those are going to be 126. 80 of those are going to be 127. Do you want me to sit here and draw 80 dots in here? No, but you get the idea. So in any sample, we're going to, if we had 100 atoms, 80 of them would be 127, 17 would be 126, and 3 of them would be 128. So if we're doing a weighted abundance of this, we need to calculate the average atomic mass of iodine. So how do we do that? Well, the first thing we do is we take these values out of percent form. So how do I take these out of percent form? How did I get them into percent form? Yeah. Okay. I got them into percent form by multiplying by 100. So if I want to get them out of percent form, I'm going to divide by 100. So 80 divided by 100 is 0.8. Yep. I'm going to multiply that by its mass then, because that means that 80% are this mass. Now I'm going to take this guy and I'm going to do the same thing. 17. I just moved the decimal over 2. And I'm going to multiply that by 126. And then I'm going to take this guy here, the 128. I'm going to multiply that or divide that by 100. What is that? What is this divided by 100? 0.03. Now, this is where people oftentimes have issues. What they will do is instead of moving the decimal 2 spots over, they only move it 1 because they're not paying attention. Okay, so be careful with that. And I'm going to show you how to double check your work in just a second. Okay. All right, so we're going to go through and we're going to multiply these out. All right. Once I have the 3 parts from this sample, I'm going to add them together. I end up with 126.86. That makes sense? Now, how do you double check your work? What you do is you want to go back. You want to find your highest number. You want to find your lowest number. That did not work out well. Okay, my highest mass and my lowest mass. This value here should be in between them. If it's not in between the highest and the lowest, you messed up. And probably where you messed up is right here. So if you make that a 0.3 instead of 0.03, this number is going to be way bigger than it should be. So go back and double check your work. Questions on this? All right. We have an isotope 1, 2, and 3. Here is their mass. And here are their respective percentages. So you need to make sure you divide these by 100, multiply by the mass, and then add everything together. Go. Why aren't you doing those? You have a calculator. You want a calculator?
Yeah, I think so.
You need to know so. That is your assignment tonight, is to find out if you own a calculator or not.
The homework?
Oh, you got homework. Upside across. And add up those values. Sorry. Turn it. All right. Did you get that answer? Now, they will sometimes ask you to identify the element that you calculated down here. So take this mass and go to the periodic table and find one that's close to that. What? Neon, right? So this is neon. This making sense? How to do it? It's the weighted percentage. You got more in there. We could do this for like number of sophomores in here, right? We have mostly sophomores in here. If we wanted to figure out the weighted percentage of sophomores in here, it would be pretty high compared to everybody else. Okay. Oh, I haven't done attendance, speaking of which. It's going to make me use my phone. No, it didn't. Cool. All right. Excellent. Sometimes we have to go on and do that dual authentication thing. Mm-hmm. Hey, is Presley back there? Yeah. Okay, sorry. Couldn't see you for everybody. So we got one. I got two seniors. I got an 11th grader and I got a 9th grader. So in this class. So if we did the weighted percentage, we would end up with like 10.1 or something. Does that make sense? Because most of the people in here are sophomores. All right, let's try one more. So try this one. See if you can calculate the average accepted average atomic mass and then identify the element. And I'll put my answer up here momentarily. Malachi, Hayden. You already did it? Because you're just that good, huh? Get your Chromebook out then. Mm-hmm. I don't think you had registered for Blackhawk, right? Hayden? My list. Where's my list? I had a list of everybody. Where did I put that? I had a list of everybody checked off. I even had this organized. I was ready to go. What would I have done with that list? Yeah, you hadn't done Blackhawk yet. Did you find your username? Did you find the email from Blackhawk? So find the email from Blackhawk, and then you should be able to find your username. You should send them an email. All right, let's go through this. I have 32 times 0.950. I have 33 times 0.0076. I have 34 times 0.0422. And I have 36 times 0.00014. Now, before we even get started with this problem, think about what the mass should be based on these percentages. Where should your mass be coming in heaviest at? Yeah. So your answer down here should be around 32 when you get done, because the majority of this sample is 32. Does that make sense? Just like the majority of you were 10th graders. All right. So let's go through here and calculate this. We got 32 times 0.95. We have, that's 30.4. We have 33 times 0.0076. That ends up being 0.2508. We have 34 times 0.0422. That is 1.4348. And I have 36 times 0.00014. And that ends up being 0.00504. So now I'm going to do what with these values? Add them together. So I ended up with 32.09064. So 32.1 if we want to round. Then I'm going to take this value and I'm going to go to the periodic table and I'm going to identify this as sulfur. Good? Easy enough? All right. So let's go through what we're going to be doing the next 3 days in class. Okay? So you have 4.2, a 4.3, and you have an isotope simulation that you're going to get done. All of this is due on Monday. Okay? So I'm just giving you the rest of the week is just going to be work time to work through this stuff. Okay? The only thing that has to be done in class is the isotope simulation where you just count the beads. Okay? Everything else has to be done by Monday, but I know the next few days are going to be rather chaotic with people in, people out. People are not going to be as focused as they need to be because of homecoming. So I just wanted to make sure that we had kind of a working days where we can get things done. We can focus on things. I can be here to help you, but it doesn't have to be something, a lot of it that has to be done in class because we're going to have a lot of people kind of popping in and out. Make sense? Does that work for you? All right. The next thing we're going to do, though, is we are going to get our application for Blackhawk